Hello everyone, welcome back to the channel, and in today's video we are going to walk through the foundations of creating a realistic skin shader inside Unreal Engine. Now, before we jump into the advanced stuff like macro normals, fuzz layer and using different texture maps, we first need a clean and a simple base material. So in this video, first we will set up a basic skin shader using different subsurface shading models. And I will also explain how each subsurface shading models behaves differently in Unreal Engine. We'll also take a look at how opacity interacts with them. There are three subsurface shading models in Unreal. The first is subsurface, the second is pre-integrated skin, and the third is subsurface profile. So let's start by creating a new material. Then create its material instance and open the material. Now because we are working with skin, we need subsurface scattering enabled. So in the detail panel, first we will select the subsurface shading model and let's see how it works here. This is the most basic subsurface model. This works well for stylized character or simple soft materials. Here I have added a simple color into the base color input. Just a soft skin tone value for now. Then I have added scalar parameters for specular, roughness and opacity and renamed the opacity to SS strength because in Unreal, the opacity controls how much light penetrates the surface and scatters inside the material. Then I have added a detail normal for this example and tiled it by multiplying to a texture coordinate and a scalar parameter. Then to soften the harshness, I have used a flatten normal node and added a normal strength parameter before plugging it into the normal input. Then again, I have added a simple color to the subsurface color input to control the subsurface color. Now here when the opacity value is 1, it turns off the scattering effect, and when its default value is 0, it turns on the effect. Here you can also change the scattering color, base color and other parameters. Now we will see the pre-integrated skin shading model. This model gives you a faster simulation optimized for animation and distance rendering. It is not as detailed as Subsurface Profile, but good for performance heavy scene like games. It works the same as Subsurface shading model. So again, when the opacity value is 1, it turns off the scattering effect, and when its value is 0, it turns on the effect. Now lastly, we will see the Subsurface Profile shading model, which is the shading model we are using in this tutorial. It uses a subsurface profile asset to simulate realistic light scattering and softness. This is the recommended option for the realistic skin. For this shading model, we will create a subsurface profile layer. Create and open it, and here you will see different settings to control the subsurface effect. We will keep a default setting for this tutorial because it gives the best result. Now here we will see that it does not need a subsurface color, and its opacity value was different from subsurface and pre-integrated skin shading models. So here when its value is 0, it turns off the scattering effect, and when its value is 1, it turns on the effect. With everything connected, we now have a clean base shader that looks soft, waxy and properly diffused, just like human skin should be, before adding macro surface details. And for that, here I have imported the face mesh and created some lights. To import the mesh, create a folder and click on import here. Then select all meshes and drag and drop them in your scene. Now that the base shader is working, the next step is to bring the actual texture maps and give ourselves full control over them. But before adding them, make sure to change the compression setting to grayscale and disable sRGB of every texture map except normal map and base color. Keep them as default. Also, if your normal map is not in a DirectX format, then enable flip green channel of your normal map. Then save them all. First, we will plug in the albedo map. This is the main color texture. But instead of connecting it directly, we will pass it through a small control chain. This gives us real-time flexibility without needing to jump back to the Photoshop or Substance Painter every time. The first parameter is brightness, which globally adjusts how bright the skin is. Change its default value to 1. Then multiply it by a contrast parameter so that we can increase or flatten the texture detail depending on the lighting situation. Next, we will add an optional tint color, which allows subtle shift, for example, increasing warmth for sunlight or cooling the skin tone for moonlight. So for that, add a lamp node and for its P, create a blend overlay node. Then connect it to the power node and a color parameter. Then for its alpha, create an intensity parameter. And finally, we will add a hue and a saturation adjustment. Change the default value of saturation parameter to 1. Lastly, we will also add a toggle parameter labeled as use albedo map. This will let us switch between a flat color and the texture map. Make sure to change the group name and search priority of every parameter as shown here. Save it and let's see our material instance. Now we will add other texture maps and also add their parameters. So for that, open our master material and add the specular map. Again, we will add parameters for specular brightness and contrast. And change the default value to 1. Then add a toggle parameter to decide to use the map or a single base value. Change the group name and search priority of every parameter. Next, we will be moving to the roughness map. Again, just like the specular controls, add parameters for roughness, brightness and contrast. And change the default value to 1. Here, we will add a toggle to invert the roughness map. Then add another switch parameter labeled as use roughness map to choose whether to use the roughness map or just a single scalar value. Again, change the group name and search priority of every parameter. Alright, now that we have set up the basic of the subsurface profile shading model and tested how opacity affected, so let's move forward and start building something closer to an actual skin material. And for that, first we will create a subsurface scattering mask. As we know that when the value of opacity is 0 or black, it turns off the scattering effect, and when its value is 1 or white, it turns on the effect. So we will creating our scattering mask according to this setting. And to create it, import a head model and a normal map into Substance Painter and follow the steps shown here. As we have seen before, when the opacity value is black, it turns off the scattering effect, and when it is white, it turns it on. So we will add a label here, then click on invert and change the setting as shown here. Here you can also add a new fill layer with scattering enabled and use it to paint more detail to your scattering map. But here I already have a thickness map with this mesh texture. So I will add the texture and change its blending mode to screen. This model also comes with a hair mask, so I will be using it here. You don't have to do this and can export your texture without using it, or you can create your own hair mask. Then export the texture and import it here. Change its compression setting to grayscale and disable sRGB. Then save it. Again, we will add parameters for scattering brightness and contrast and change the default value to 1. Then add a toggle to choose whether to use the scattering map or just a single scalar value. Change the group name and sort priority of every parameter. Next, let's move to the normal map. Add a flatten normal. This will allow us to add a strength slider for the normal map. Change its default value to 1. Change the group name and sort priority of every parameter. Now, lastly, let's add the ambient occlusion and curvature map. These two maps helps define cavities and edge to add more natural shading variation. Here, we will add a contrast parameter for both maps. Change the default value to 1. Then blend them together by using a multiply node. Then create a toggle to use or not use the curvature map. Again, change the group name and sort priority of every parameter. Lastly, make sure to create comment box for every texture map and connect them to the respective material pin to make everything look neat and clean. Save the material and let's see our material instance. Next, we will add albedo first to the material. First, help simulate those tiny microfibers on the skin surface that catches highlight at a glancing angle. And for that, add a Fresnel node. Then connect this output to a multiply node. This lets us control its strength. Then run that through a power node. This sharpens or softens the highlight. Finally, blend the first contribution with the color parameter using an add node. Then connect the add to the switch parameter. Change the group name and sort priority of every parameter. Now we are going to add specular fuzz. Just like before, we will multiply the fuzz output by a parameter to control its strength and then add it to the main specular value. Lastly, connect the add to the switch parameter. Again, change the group name and sort priority of every parameter. Save and let's check the material instance. Now let's refine our roughness by using an RGB mask to control different regions of the face individually. Right now the roughness map is affecting the entire surface evenly, but the real skin doesn't behave that way. The nose, forehead and lips all have different oil levels. So to fix that, we will use an RGB mask where each channel represents a specific facial zone. To create it, let's go to Substance Painter and follow the process shown here. Export the texture and import it here. Change its conversion setting to mask with nose RGB. Here, the red channel controls the nose area, the green channel controls the forehead, and finally, the blue channel controls the lips. Save and add it to a material. Create 3 1 node, then connect the mask to them. Again, create 3 LARP and constant nodes. Then change the default value of the constant node to 1 and connect them to the A of the LARP node. Then connect all 1 nodes to the B of the LARP nodes. Now create 3 parameters for the alpha of each LARP node, which will control the intensity of each roughness mask. Then multiply them by each other and finally multiply them by your final roughness map. After that, connect the final multiplier node to a toggle to switch between using and not using the roughness mask. Then connect it to the switch parameter created before. Change the group name as short priority for every parameter. Now that the primary normal is in place, the next step is adding a detailed normal layer. This allows the skin to retain the macro surface definition. Again, we are going to use an RGB mask to drive this system, where each channel controls a different region of the face, like cheeks, forehead and nose. We will also using a separate detailed normal map for the entire head. Now, to create the mask, we are gonna follow the same process as shown before. So, here are the fill layer and the blur settings. Again, export the texture and import it here. Change its canvas setting to mask with no RGB. Now add the mask and every detail normal map here. You don't have to fill up their green channel because they are already in DirectX format. Then multiply them by a texture coordinate and a parameter to control their tiling. And use flatter normal to control their strength. Change the default value of the strength parameters to 1. Now blend each detail normal to the main normal using the blend angle corrector normals node. Then create lap nodes for cheek, forehead and nose detail normal map. Connect the main normal map to A of each lap node. Then angle corrected normals of cheek, forehead and nose to B of each lap node. Then connect RG and B of the mask to the alpha of each lump nodes of its detail normal. Add the final results to each other. And create a toggle to switch between using and not using the detail normal map. Connect the main normal and final detail normal to it. Finally, connect it to the material. Change the group name and sort priority of every parameter. Save and let's check the material resistance. Now to finish the albedo pipeline, we will be adding a custom blur and a eye bag mask. This gives the face more natural variation and avoids the flat uniform look. Again, to create the mask, follow the same process as before. And here are the fill layer and the blur settings. Export the texture and import it here. Change its configuration setting to mask with no sRGB. Add the mask here and start by multiplying the mask with a color parameter. This gives us full control over the hue. Next, the result is multiply again using an intensity slider. Change the default value to 1. Then add them to each other. Finally, add it to the final albedo map. Create a toggle to switch between using and not using the mask. Then connect it to the final base color switch parameter. Change the group name and sort priority of every parameter. Save, and let's check the metal instance. And that's complete the full breakdown of the skin shader setup. If you found this helpful, make sure to like this video and subscribe to the channel. Thanks for watching, and I will see you in the next tutorial.